Now I would be talking about one innovative way of the tile fixing. Yeah. So the concept is called as the bactile bonding primer. Okay. So if I have to see the current market trend in the ceramic tile installation, so you could see that the tiles are becoming bigger and bigger. Yeah. In the past we were quite seeing the tiles which are 1 feet by 1 feet or maybe 2 feet by 2 feet. But the now tile size is becoming big and big. Yeah, and the largest tile which is available in the market, to my knowledge, is around 4 feet by 8 feet. The second market trend is, the earlier days we used to have the ceramic tiles, which were having the higher water absorption, let's say above 15% or around 15%. And now with the change in trend, we could see that these ceramic tiles are being getting replaced with the vitrified tiles. Yeah, and the vitrified tiles, water absorption is very less. Now the vitrified tiles which are available in the market are having water absorption less than 0.2%. And typically if you see, most of the people, they just use cement and sand to fix these vitrified tiles as well. Yeah. So ultimately what we could see is that there is an increase in failure of the tiles. We could see the tiles getting debonded easily. Yeah. So this is the thick bed and the thin bed technology which is typically available in the market. So thick bed technology is typically a traditional way of a tile fixing, where you lay a cement sand mortar, sometimes called as a machan, and then you fix it with the cement slurry. Yeah, so this is a thick bed method. And then there was introduction of the thin bed technology, popularly known as the tile adhesive technology. Yeah, so when this thin bed technology was launched, it was assumed to be a cost effective and a clean way of the tile fixing. But if you do the cost calculation, the thin bed technology is cost effective till a bed thickness of 4.5 millimeter. The moment you go above 4.5 mm, the thin bed technology becomes expensive than the thick bed technology. Yeah, and that is the reason still around 85 to 90% of a market, if you see, uses the thick bed technology, which is the traditional way of a tile fixing. And only 10 to 15% of a market uses the thin bed technology, which is a tile adhesive. In tile adhesive also, if you see, categorically high-end tile adhesives are very less, and still the market is ruled by the low-cost tile adhesives. Yeah. So the advantage of this bactile bonding primer is it can also be used for the traditional way of a tile fixing, and it can also go as a complementary product with the tile adhesive to improve its performance. So if you see, this is how it is done. So you have a cement sand mortar or a wall on which you apply this tile adhesive or a cement sand mortar, then you fix a tile. But over a period of time, what we see, the tile debonds. And if you observe the debonding of a tile, you could see that tile comes very neat and clean, as if nothing was applied onto the back of a tile, no adhesive was applied. Okay. So now here what we are proposing is that you can go ahead with whatever the methodology you are using. Only thing is that we are advising you to apply one thin coat of a bactile primer, and then you fix a tile the way you are fixing your tiles. But this thin coat of a bactile primer helps you to increase the bond strength, then increase the water resistance, because this also acts as a thin coat, a waterproof coating, so it also stops some water migration, and also efficient cost in use. Yeah. So if you see this traditional method, this is a traditional method wherein this thick bed you can see is basically the expanded view of your thin bed of a tile adhesive, and these red dots, what you see inside this is basically the polymer particles which are used into the tile adhesive formulation. Typically these are the redispersible polymer powders used. Now whenever you put this redispersible polymer powders into the tile adhesive, what happens is that these polymer particles gets distributed throughout the bed thickness. Let's say it's a 6 millimeter bed thickness or 12 millimeter thickness. So these polymer particles will get distributed throughout the bed thickness. Either it could be a 6 millimeter, 3 millimeter, 12 millimeter, depending on to the tile size. Now what happens is this polymer is not actually required within the bed of your tile adhesive. Actually failure is happening at the interface of your tile adhesive and the tile. And the major requirement of a polymer is where the failure happens. Yeah. Now what we are doing with the bactile bonding primer, when you are applying the bactile bonding primer onto a back of a tile, so all the concentration of a polymer is happening at the interface where the failure is happening. Yeah, and that's how it is also cost effective way. It's not getting distributed throughout the bed thickness. So this is some data which we have studied in our Shanghai lab. We also have done some third-party testing in our India labs. So here, if you see, here you could see different graphs. So in the gray color, you can see it's a normal cement and mortar, and in the blue, that same cement and mortar, but with the bacterial bonding primer. So here you can see there is a significant improvement when it comes to the room temperature. Yeah, and typically, if you fix tiles with the cement and mortar, that also does the job. Okay, it will remain there for a certain period of a time. But if you see the tile failure, it would be happening because of the temperature fluctuations, water exposure. Yeah, so here it's clearly visible. If you see this graph, in the heat condition, the mortar which was giving around 0.85 of a pull out is dropping to 0.03. Yeah, and in the water immersion, it drops to 0.14. So if you see the performance improvement what you could get with the simple cements and mortar just by use of a single thin coat of a bacterial bonding primer. So that is how you can see it here.